trigonometric equations, right? Let's say if you are given a trigonometric equation like say sine theta, okay, sine theta equal to, well, maybe say 0.6, okay? Now, if you solve it and you get to sine theta equal to 0.6, in grade 10, there was a restriction always which said theta, okay, say, okay, 0 degrees. And in grade 10, there was a restriction which said theta lies between 0 and 90 degrees. Do you know why? How many of you know why in grade 10 we had that restriction?
We didn't know general solution.
Yeah, but now you know, because you did grade 11, but do you know why in grade 10 you had that?
So they wanted to tell us which project to use.
Or rather, do you know why we have to find the general solution in the first place? Raise your hand if you know. Raise your hand. If you have got confidence, full confidence as to why we have to find a general solution of trigonometric equations. Raise your hand if you have got the confidence and you really know. So only 2 of you there raise it. So the rest of you don't really know. Okay, hopefully after this you know. You see, when we talk about trigonometric equations, we have to incorporate trigonometric functions. We cannot talk about trigonometric equations without incorporating trig functions, because there is a relationship. All right? So in grade 10, the reason why you were given this restriction here, it was mainly because this trigonometric equation, it has got an infinite number of solutions, from minus infinity all the way up to positive infinity. There are so many solutions. If you were to ask you to find all of them, you can spend even years trying to find all of them. There are so many. Why? Because the sine function, the cosine function, the trig function, they are periodic functions. They are periodic functions. So the purpose of the general solution is to simplify or to get a formula, or rather I would say the general solution is just a formula that you can use to determine all the possible solutions. It's a formula that you can determine all of them. So it just generalizes it actually generalizes all the possible solutions. So when you find the general solution, you are finding a formula that you can use to find all the possible solutions to a trigonometric equation. Okay? This equation which I have written here, it has got an infinite number of solutions. You can spend probably the rest of your life trying to find all of them. Now, who has got the time to actually do that? We don't have the time. That's why when you write an examination or if you read widely, sometimes there's a restriction which is provided. The purpose of the restriction is for you to find probably just a few of the solutions, but they are not the only ones. There are there are so many of them. Okay? So the restriction just makes it a little bit easier in terms of finding just a few of them. But it won't mean that those solutions are the only ones. They are not. They will be the only ones for that specific restriction. Okay? Now, when you say theta is equal to shift sine of 0.6, like that, the moment you write shift sine, the angle that you get here is called the reference angle. Okay? That angle is called the reference angle. It is the first solution to the trigonometric equation. Okay? And it is the key to finding all the other solutions. Now the interesting part is it can be negative or it can be positive, depending on whether this ratio here is positive or negative. Okay? But this, when the moment you say shift sign, shift cos, shift tan, that's the reference angle. Because the trigonometric functions are periodic, you can use that reference angle to determine all the other possible solutions based on the cast diagram. All right? Now, if, okay, here I've got a graph of, I can't write, let me take it to my e-beam quickly. I can't write, unfortunately I can't write on it. Technology doesn't allow me to, but we can do the other way around. Okay, so we have got a nice curve there. Now, this function here, if I were to ask you, what's the equation? Or what would be your answer?
Sine x.
What's the equation?
Sine x.
Huh?
Sine x.
Okay, you can say y equal to sine x, right? So you can say y equal to sine x. It's actually y equal to sine x. Okay, let's use that color which is a little bit better. So this is the graph of y equal to sine x. Or you can say y equal to sine theta, whichever the case. Now if you look at it here, I never gave a restriction as to how far I'm supposed to go, but I only drew it from minus infinity. As you can see, it goes all the way to negative infinity, and then on the other side, positive what? Infinity. But here, based on the graph we have here, in terms of calibration of the x-axis, we have got from minus 1080 degrees up to 1080 degrees. All right? Now, in this case here, I said let y be equal to minus 0.5. So y is like, it's a ratio. Because when you talk about trigonometric equations, you have to incorporate equations. There's a relationship. Okay? You cannot study trigonometric equations or the general solution without the trig function in mind. So this ratio here, it's actually y on the graph. Okay? It's y on the graph. So for this graph here, I said my y is negative 0.5. So that's equal to sine x. Okay? Now if I were to ask you by observation, how many solutions are we going to have for this trigonometric equation? Sine x equal to minus 0.5. How many solutions are there?
On the graph.
Yes. From what you're observing here, how many solutions to that trigonometric equation? There are how many? There are what? 13, right? There are 13 of them. Okay? So because here I made it a little bit easier for you to see. This is a horizontal line. The line is y equal to minus 0.5. So where this line intersects with the sine graph, that's where you've got the solutions. Okay? So we've got 13 of them. Does it mean that we only have 13 solutions overall? No. We have an infinite number. So you can't even find all of them. You spend probably the rest of your life and beyond trying to find all those solutions. There's so many. So the idea of a general solution is just to get a formula that can help us to find all the solutions. And here, your reference angle is here. Okay? This is where your reference angle is at G. Because the ratio is negative. Shift sign of a negative 0.5 will give you minus 30 degrees. Now, I'm sure you can agree with me that some of the solutions that they are negative, others are what? Positive. Right? So, when you are finding the general solution, You don't have to convert the reference angle. If you get it as a negative, convert it to a positive. That's wrong because this part here, k times 360, it caters for both negative and positive angles. Remember, your integers are both negative and what? Positive. So I'm going to give you an example of what I mean. Because I have seen this and I wonder why. Right? You get theta, let's say here. What is shift sine of 0.6? Okay, let's change this to minus. And then shift sine of minus 0.6.
Negative 36.87.
Negative 36.87. Right. So if I write the general solution, it will be plus k times 360 degrees, where k is an integer. Then the second one, because sine has got two general solutions. There are two. Since the ratio is negative, right? The first general solution in terms of the reference angle, in this terms of this reference angle, that reference angle there, it is in the fourth quadrant, right? There is no need to convert it to a positive because of this k times 360. If I put k equal to 1 here, I'll get the angle in the fourth quadrant as a positive. There is no need to convert this reference angle to a what? A positive. Because this k times 360, it caters for all values, whether negative or what? Positive. You'll be wasting time to convert it to a positive because of this. You leave it like it is, like this. Alright? Then, to get the second one, it will be theta equal to 180 degrees, right? Minus, because this angle is in the fourth quadrant. We want to find its sister or brother in the third quadrant. Because sine is negative in the third and what? And fourth. So we subtract the reference angle from 180. Right? Then we write that. Okay, so this will give us 216,87 degrees plus k times 360 degrees. There is no rule which says your general solution must have this part with a positive angle. No, that's wrong. Because this k times 360, it caters for all solutions that are positive or negative. Once you get your reference angle from your calculator, that's like your pivot point. Okay, that's your reference. You can get another point along that function from it. There is no rule which says your general solution must be written using positive angles. If someone told you that that's not correct, because the solutions, as you can see here on the graph, they can be both positive and what? Negative. And the reference angle can also be negative. There is nothing wrong with the reference angle being negative. And you don't have to change it to positive because the k times 360 caters for the positive side. You understand what I'm saying? Yeah, there's no need. Right? So, take note of that. Right? You can also have your ratio being positive. So all these points here, that will be the solution. The reference angle can be positive or negative. Once you convert it to a positive, if it was negative, it's no longer the reference angle. The value that you get from your calculator, that's your reference angle. When you say shift sine, shift cos, shift tan, that's your reference angle. Because of the periodic nature of these graphs, you can use it to find all the other solutions. Right? Now, this is very interesting. If you look at this graph, right, in terms of quadrants, let's say here, if you look at the case where our y is negative, first quadrant and second quadrant in there, right? Then from here now, we have got our third and fourth quadrant. Do you see that? Then here we move on, okay? That's your revolutions now. All these are what? Revolutions. If you go to the other side, this will be the fourth quadrant, this angle, because it's negative 30, and then this one here, it's going to be 210. That will be negative, minus 150, this one here. It will be in the what? Third quadrant. Then you have your revolutions. All that. All. And how do you get the others? It's because of this part. The k times 360, this part. That k times 360 is very, very important because it explains the fact that the function has many solutions. Okay? And also this. If anyone tells you something else, you have to challenge them. Why do you have to convert the reference angle to a positive? Because it's a solution itself. The reference angle itself is a solution to the trigonometric equation. It's actually the first solution to the trig equation. Because when k is 0 here, your answer will be that. And if you plug it in here, you will get this ratio. Okay? The good thing about the general solution is that you can test your solutions if they are right or wrong. Right? So, your goal, whenever you get any question on the general solution, it is to simplify the trigonometric equation. Can you pay attention? First, you memorize this 5 formula. If you memorize this 5, you're okay. But what you need to know is that whenever you get any trigonometric equation, if it's in terms of sign, you have to simplify until you get that. That's your main goal. Okay? Then, if it's a cosine equation, you have to simplify until you get that. If it's a tangent equation, you simplify using all the various techniques or all the various concepts until you get to tan theta equal to a ratio. Then you make theta the subject, you add your k times 180, but don't forget to write that k is an integer. What you should be stressed about is how to simplify the equation to this. Okay? You just memorize those 5 formulas and then you are done. No stress. You don't have to have a heartbeat increase because you saw a question on the general solution. It's so easy. So easy. Okay. I think I'm done with what I wanted to say. I don't think I've got anything more. You memorize this. What I wrote here. A, B, C. Be aware that there are 2 general solutions for cos, for sine, 2 for cos. Okay? And then you have got 1 for tan. Once you do that, you're okay. You can challenge anybody if you just use that. Yes?
So for the question that you did as an example, you take that answer between 0 and 92.
That was in grade 10.
No, for this one, the one you just showed us now, you take that difference between 0 and 92.
That's not what I said. You didn't understand me. I said in grade 10, you were given a restriction. Why the restriction? Because it was being simplified for you. Because you were in grade 10, you had not been introduced to the concept of the general solution.
So if you're given a restriction, we have to find the actual
value. You can determine your general solution first, then you use it to determine all the other solutions. Okay, you have to find your general solution first and then use it by substituting the values of k. Okay? Is there anybody who has got any question before I talk about this question that Tyra asked me? Now, because you are in grade 12, is there anybody who has got a question? And the other thing, just to let you know, because I've seen a lot of stuff, there is no need to write quadrant 1, quadrant 2. There is no need for that. Do you know why? Okay, yes, I'm telling you this. Because people teach this in a wrong way and they confuse other people. There is no need for that. You see this. If they pay attention. If A is positive, once you say shift sign A, you get an angle in the first quadrant. And then you subtract it from what? From one end, you get the other one in the second quadrant. If it's negative, once you say shift sign, you get the fourth quadrant one. Then you subtract from one end, you get the third quadrant. So there's no need to waste time writing quadrant 1, quadrant 2. For what? There's no need for that. Okay? And here too, for course here, the plus or minus caters for both quadrants. When the ratio is positive, you get a plus or minus a reference angle. The positive first quadrant, the negative fourth quadrant. So you waste time trying to write quadrant 1, quadrant 2. It's a few seconds of your lifetime that you are wasting. And there is no mark allocated for writing quadrant 1, quadrant 2, quadrant 3, quadrant 4. For what? For what? You just memorize this, you're okay. If you understand what I'm saying, you make things easier for yourself. There is no mark given for writing quadrant 1, quadrant 2, quadrant 3, and whatever. Okay? I laugh when I see all that because it's not necessary. You should understand this formula. If this formula here, they cater for all quadrants. For any quadrant. If you understand your stuff, you won't have any stress. Okay, Joseph? Have you ever seen me writing quadrant 1, quadrant 2 since last day? I'm not mentioning anyone. Okay, I'm not mentioning anyone. But I'm just letting you know that it's not necessary. The few seconds that you've been writing that for nothing, because there is no mark allocated for writing that. You just memorize the formula. Memorize the formula. This formula here, they cater for all the quadrants. If you understand what I'm saying, you are gonna be fine. You won't have to stress. Alright, let's carry on. Do you understand what I'm saying? Yeah, okay, I'll just give you an example. Especially for cos. Cos is interesting because this plus or minus, it caters for both cases when the ratio is positive, quadrant 1, quadrant what? 4. The negative angle caters for the quadrant 4, the positive quadrant 1. If the ratio is negative, it means the plus becomes a minus, the minus becomes a what? A plus. So the positive, negative, it will cater for the second and the third quadrant. That plus or minus there, it caters for all the quadrants. So there's no need to write quadrant 1, quadrant 2, no. Even also the other thing, there is no mark for writing the reference angle equal to. There is no mark for that because the reference angle is this one here. That's the reference angle. This one here. That's the reference angle. That's the reference angle.
If tan is negative, it's still going to get the same.
Yes, it's going to be the same. Okay, yes. Yes, like how I taught you, Sayana. How I taught you last year. All right, let's carry on. Okay, so allow me to carry on. Okay, I've got this question that she just gave me. Let me talk about it now. Okay, so we have got 2 tan x minus 3 tan x plus 1 is equal to 54. Okay? Now, if you want to do this question here, obviously, you have to apply your knowledge of what? Exponents. Okay? Your knowledge of exponents. So, we can write this as 3 times 2 tan x minus 3 tan x times 3 to the power of 1 is equal to 54. But I can simplify that. So I can write it as 3 tan x. Then I can put the 2 outside minus 3 tan x times 3 to the power of 1 minus 54 equal to 0. Okay? Hope you saw what I did there. Right? Then use the K what? K method. Right? K method from quadratic equations. So let K equal to 3 to the power of tan x. So you get K squared minus 3K minus 54 equal to 0. And then there you get K minus 9, K plus 6. Okay, so K minus 9 equal to 0, or K plus 6 equal to 0. Okay, then obviously you get K equal to 9, or K equal to minus 6. Right, then you substitute back that. Okay, are you following? Right. The question, we want to find the general solution, right? The hardest part, I've already done it. Okay, yes.
So with the 3 to the power of 1,
Okay, 3 to the power of 1 is the same as 3.
yes.
Remember, 3 to the power of 1 is the same as what? 3.
You're still going to get 2 as an answer, but you'll get an
Look,
additional.
okay.
You'll get an additional.
3 to the power of 1 is equivalent to what? To 3.
Negative log. So your
Yes, so 3 times what? K.
Your answer will be a negative log. Yeah.
Alright?
So this is so awful.
Why?
Okay. Could you have done it a different way, where you just factor out 3 tan x? Because now when you put it back in, you're still gonna get tan x is 2, and then you'll also get tan x, and then you can do like tan x is a log of a negative number, so you're just gonna get 2 as your answer.
I'm not going to introduce logs.
But then,
Wait, I'm not going to. You see, the reason why I have to use this approach is because this equation here, it's more complex. Yeah, it's a little bit complex. It's not as simple as you might think. Yeah, it's a little bit complex. So we have to find a way which will make it easier for us to factorize and get to this point. So now I've got my 9 here, so it will be 9 equal to 9 equal to 3 to the power of tan x. So this gives me 3 squared equal to 3 to the power of tan x. So tan x is equal to what? To 2. Now, check this. My general solution. I've got this. Right? No stress. No stress at all. You see this? Right? So I'll just say theta equal to, so I'll write it, theta equal to shift tan of 2 plus k times 180, where k is an integer. Then you get what? What is shift tan of 2?
63.
So you get 68.
63.
63. 63, comma 4, comma 43 plus k times 180, where k is an integer. And then you are done. Okay, you are done then. Okay, then we do the second value for k. Right, no stress. You are done. This is the general solution.
yeah.
Right? Then minus 6. So we are going to have minus 6 equal to 3 to the power of tan x. Right? Now, if, I'm sure you can see that this is a negative. If you try to take logs of this, you get an undefined answer. Right? I'll show you one. So, if you want to convert that to logarithmic form, remember the base of the exponential is the base of the logarithm. Right? So this will be log to base of 3 of minus 6 is equal to tan x. Now, you cannot find the logarithm of a negative number. The logarithm of a negative number is what? Undefined. So here we just say, you know what? No solution.
You have to show that.
Well, it is possible that a mark might be allocated for it. So it would be wise just to, okay, no, not the working out. But from here, you can go straight away. Yeah. You can, from here, you can go straight away. Okay, and then you are done. And now, look, this question, sorry, China, was it from a grade 12 paper? Yeah. Is there any grade 12 concept that we use there? In actual fact, the bulk of it is actually grade what? 11. It's only this part where I wanted to show where you get your grade 12. Yes. So the bulk of the concepts required for this question is grade 11. Okay. All right. Okay. I'm done. Okay, let's come back to, let's care about this. Let me do this one quickly as an example. Right, so I'm finding my general solution, and there's no stress here. It looks like it's scary, but it's not. Right? Yes, because some of you get so scared when you see the equation. Right? So this will be 12 sine squared x. Now, this one here we are going to convert it. Okay? So it will be 2 sine x cos x minus 4 cos squared x equal to 0. Okay? Now, because of this term here, okay, I may not have to convert that cos squared x to sine squared x. Right? I have to factorize it like that. So you must give me the factors. So what will be the factors?
So then can you take out a common factor first?
Factorize. You can take out a common factor if you want. Okay, if we take out the common factor 2, listen, we'll end up getting 6 sine squared x minus sine x cos x minus 2 cos squared x equal to 0. So whether you take out a common factor or not, it can be factorized. So what are the factors? What are the factors?
3 sine x minus 2 cos x.
All right. If you think you can get confused to factorize it, you can say let a be sine x, let b be cos x. Then you go back to algebra. Okay. Right. Because there are two trigonometric ratios here. We have got sine and cos. So you can treat one as your a, the other one as your b. So what are the factors?
3 sine x.
No, I didn't cross out. This was already there. Okay.
Oh, sorry.
Let's take it out to avoid issues. Give me the factors.
Oh, it's 3x minus 2
3x
minus 2.
3 sine x minus 2.
And then 3x. Oh, 3 sine x. 2 sine.
What's happening?
We need to have the sign here. 2 be a 2. 2 sine x plus 1.
Plus 1.
Okay, but what about the cos? What about the cos? Where is the cos? Which step?
Can you do what you said? Like let a equal to sine x.
Okay. I think that would be probably the best way to go. Because I think Right, so what I'm gonna do, okay, I'm so sorry that I'm making some assumptions here. I'm not supposed to make some assumptions. Alright. Yeah, I made an assumption which is not a good thing. So let A be equal to sine x and B be equal to cos x. So that equation becomes 6a squared minus ab minus 2b squared equal to 0. Okay? Then you need to factorize it now. So if you factorize it, okay, so I've got 6 a by 8 is a squared. I can have 3a by 2a equal to 6a squared. And this one here, I'll get minus 2, so that's minus 2 by 1, or 1 by minus 2. So if I want to get that minus there, multiply this one by 1, and then those 2. Okay, I didn't want to do this straight up factorizing for people.
Can you share with us what you're doing on the side?
How do we do this?
What are you doing on the side?
No, I'm trying to factorize. Remember?
That's what we
Okay.
need to know.
Okay, all right. Okay, look here. Can you pay attention? No, it's a good thing that you are asking. You see, if you want to factorize a trinomial, you look at the first term and the last term. The middle term is automatic. Remember I told you that, right? So 6a squared can be written as 6a times 8 or 3a times what? 2a. Then here we look at the coefficient of b squared, which is minus 2. So minus 2 can be written as minus 2 times 1 or 1 times what? Minus 2. What's the coefficient of AB there? Minus 1. So we need to find the correct combination of factors of the first term, that is any of these two, right? And then we choose the best of those two as well, in order to get the what? The minus 1. So I have seen it already that if I multiply 3a by 1, I'll get a positive what? 3. Am I right? Then if I multiply the 2 by minus 2, I'll get minus what? 4. So minus 4 plus 3 will give me the coefficient. Are you following?
Okay, so
Now I'm going back to grade 10, so that's what it is. Huh? Let's just run through the answer. Because you see, okay, listen, okay, talk it. You see where I am here? That's where the problem is. Okay? You might know the answer, but does everyone know? Okay, are you following what I just said here? If you want to factorize that trinomial, know that there are two possibilities for the first term, right? Then there are also two for the last term. That is the coefficient of the last term. So you need to choose the best combination among these two and also among those two, such that if you multiply the factors and add them, you will get what? The coefficient of the middle term. Okay, unfortunately I can't go back to the basics of factorization at this stage. You understand? Huh?
So just do it the other way.
Okay.
6 times 2.
I can, yes. So here, for me to get that A now, it's gonna be 6a squared. 6a squared. Okay, let me, like there's a step which I didn't write there. Let me add that step. You see, I don't feel comfortable to go into the details of factorization. So 6a squared minus 4a, okay, let me write it as 6a squared plus 3ab minus 4ab minus 2b squared equal to 0. So I'll get 3a times 2a plus b, right? Then here I'll get minus 2b times 2a plus b. Okay? This is equal to what? To 0. The problem also, because I had the privilege of marking that question on the general solution. One of the key things which I saw is factorization is a problem. I'm telling you, Sean, factorization is a problem. For grade 12, it's a problem. If you you forgot how to factorize, refresh yourself. Refresh yourself. Okay? And don't come to a maths paper 2, you don't know how to factorize. Right? So, I got my factors here. So this is 2a plus b times 3a minus 2b equal to 0. So now I'm going back to cos now. So this will be 2 sine x plus b. B is what? Cos x. This is 0. And that one will be equal to 3a, 3 sine x minus 2 cos x is equal to 0. Right? Now, I know that once I've got a combination of cos and sine like that, I have to create what? You have to create tan. Right? You have to create what? Tan. So the first one we'll get 2 sine x equal to minus cos x. The second one, are you following? Okay, I'm so sorry that at this stage I don't have time to go into the details of factorization. You need grade 10. You need to go back yourself and refresh. So that's 3 sine x equal to 2 cos x. Then you divide both sides by cos x. So you get 2 tan x is equal to minus 1, which is the same as tan x equal to minus 2. Already I'm smiling, my general solution is almost done. And then here, you divide both sides by cos x. Oh, okay. Yeah, I'm rushing. Right, because our lesson is almost over. So this will be minus a half. And then here you get 3 tan x is equal to 2. So tan x is equal to 2 over 3. Now check this. The general solution, no pressure. X equal to shift tan of minus a half plus k times 180. Where k is an integer. What is shift tan of minus a half?
Negative 26.57.
Right? No need. Listen carefully. Hey, listen carefully. If anybody tells that you must convert this angle here to a positive, that's not correct. This is that's your reference angle. This is your solution. The k times 180, it caters for all the solutions, including the ones that are positive. Right? Then for the second one, you have x equal to shift tan of 2 over 3 plus k times 180, where k is an integer. What is shift tan of 2 over 3? Huh? 33.69. Okay, where k is an integer. Then you are done. All right. Wait.